Hello, everybody. My name is Joseph. I'll be talking about how we provide scalability for pirates, lizards, and zombies via man, our service, well, distributed services platform. So, quick bit about myself. Who am I? I'm a software developer at MPC. I've been working with Python since about 2009. Love services and pretty much anything that is plugin based or service architecture based. Obsessed by monitoring, which I guess I'm not the only one here after various 3 a.m. phone calls. And yeah, that's my Twitter if you're interested. So as MPC, we create visual effects. These are a couple of the movies that we have been working on recently. And we do advertising and feature film for pretty much for that. And we do that across 8 sites. So I'm stationed in London, but we got sites all over the world. I think there's about 2 hours a day when there's nobody in the office, and that's when there's no deadline, which is probably never. And we got a fully integrated, what we call cross-site pipeline. So we got our own network. We make sure that everything flows from one side to the other. So what are visual effects? I guess not everybody here might be familiar with what visual effects are. That's the Wikipedia quote, but it is pretty much anything that could damage or hurt a pretty actor. So we try and avoid, putting somebody like Tom Cruise in a ship that is in the middle of an ocean and, tends to sink. So I think this is probably a bit clearer as we're actually doing. This is a shot from World War Z as we got it in from the client, and this is what we did to it. So everything that you see in the background here is absolutely completely fake. Or for this one is Godzilla, which I'll be talking about quite a bit. This is once again what we got in, and this is what we actually did to it. If you look, even the guys in the tank get replaced. No. So how does this generally work? So just a quick overview of our production workflow. Sorry, I'm going very quickly over the slides. You guys got promised a lot of stats and graphs, so I'm just trying to get to those ones. So we pretty much got a modeling team where there's an artist who does his magic, and they create a daily. A daily is pretty much a short, tiny film of the work they have been doing for a day or for a couple of hours that need to be approved before it gets sent to the next department. That goes to a review stage with the supervisor. That one can decide to approve the asset or add comments, and it can go back to the artist. And we create multiple versions over time. At some point, that get released from the modeling team, and it needs to go to the texturing team, who will actually be creating what it looks like. The skin of somebody like Godzilla. That's the texturing team that does that. So we need to make sure that when they release something, a notification is sent to all of the different artists that it was released. We need to make sure that all of the dependencies of those specific assets actually are being transferred as well. And we need to maybe sync it to a different site depending on what site we're working. And at that point, we pretty much go through the whole same thing again, over and over and over again, until we're at the final image. So a couple of things that we have to keep in mind. So assets. We release thousands of assets a day. Sometimes we release hundreds of assets a minute. Depending on how busy things are. Production schedules, they change every single time. There's a fixed deadline that we need to make, but at some point you might just get an email and, hey guys, we need a trailer by the end of this month. You flip everything around, and you need to be able to scale at that point and make sure that everything still goes through the system fluently. And we have to deal with users. Of course, we have to deal with them. We've got about 2,000 artists, and we've got a development team of about 100. And the infrastructure team, we pretty much sit between where the developers are and the systems. We sit right in the middle, and we take care of actually making sure that what they write goes through the back end. So we've got various sources that people use, our in-house tools that we write, third-party applications that we work with. And the one thing that we have is that we work with multiple environments. We don't have one single environment. Every show has its own environment, and every team on that show can have their own environment as well. So everything can change relatively quickly. And we need to make sure that when they change something, we are aware of that change and make sure that things are still going through. The other one, like I said, we have the users. We've got artists who are not necessarily trained developers, yet they quite happily hack away. So at that point, instead of having 100 developers who you can tell them to write tests, you've got 2,000 developers who hack away. And then we've got the developers themselves who are not necessarily trained developers for anything that is architectural distributed services across 8 sites. They tend to be more involved into C++ and the graphics kind of things. Other ones are more involved in asset management, but none of them have been specifically trained to actually deal with distributing services. So MPC's approach was to write a service-based architecture. We pretty much as the infrastructure team provide a platform as a service to all of the different users and all of the different developers. It's a platform that's multi-protocol, multi-transport, and multi-concurrency. I'll be going to every single bit in a second. And we provide or we try and provide an ecosystem to write a service for developers any level. So anybody that comes in on the first day should be able to write a service and have that in production by the end of the day. We do everything with Python, so the whole system is written in Python. And the first generation was written in 2007, and the second generation was written in 2012 and went into production in 2013. The reason we stepped away from the first generation was because it didn't scale. It was all fine and happy when we were working on a couple of movies a year, and then something like World War Z comes along and you throw 6 million zombies at it. At that point, it doesn't quite scale as well as you would anymore, because the system that we had was a push system. So every single time a new request came in, would actually spawn a new thread. If you throw 6 million zombies at it, you spawn 6 million threads. The system goes down. So the second generation that we built is actually a pooling system and a queue-based system, which works a lot better. So some statistics. Rendering is pretty much creating the final image that is going to be shown on screen. And to render the whole of Godzilla would have taken 450 years to actually render on a single machine, which is pretty much we had to start rendering 50 years after the death of Henry VIII to get it done last May. It produced, just this movie itself produced 650 terabytes of data, which is 41,000 mobile phones. So if you don't know how much that is, I did a quick math. If you look the size of the new iPhone, if you stack 41,000 iPhones on top of each other, you got a stack that's about as high as the Eiffel Tower, just to give you a bit of an idea. And then, so that generated about 250,000 Amanda requests a minute during that movie. And that's about 4 times the Germany versus Brazil twist during the World Cup. We just do it on a daily basis, really. So Amanda itself. So this is pretty much me going to some more technical parts of it. I'll try and go through this quickly. I won't be stepping into too much of the actual coding details, although there are some slides in there. But the presentation there's a different presentation online for EuroPython where I actually go into more details for these things if you're interested. So this is pretty much the system that we built. We've got a service provider, we've got a service, we've got proxies, and we've got queues. That's all we got. And from there, so let's start with that service. Sorry, I saw you taking a photo. Cool. So we've got a service here. And all that service is a class. There's nothing else to it. That's all it is. And that is something that somebody that comes in on one day should be able to write. If you can't write a class, you know. And that is pretty much all there is. We got those decorators here, which is Python specific, where we can say public, private, protected, where we can actually expose them to the outside world. So we pretty much define the APIs that people can use. So we got a service, but you know it's not doing anything other than greeting a director, which is your typical hello world. So actually, let's make it do something. So we're going to go and check if some data exists. For my service, I want to check if something exists on disks. And we make sure that every single service is one specific topic. So we've got a storage service, we've got an asset service, we've got a config service. And if I want to use those services, I have to declare a dependency on that service to actually use it. So in here, I can say I'm going to be dependent on the storage service and use the service to check if it exists. Later on, we want to get some information out of a specific shot. And for that, we use what we call infrastructures. And that's pretty much our way of giving to the developers that have just joined a way of using a database or using configuration or using things like logging. In themselves, they are services and they are stateful services. All of our services are stateless except for those ones. And that allows us to do pooling, caching, and a whole bunch of other things that actually allow us to assign a request context to a specific request that comes in. So for every single request that comes in, we generate a new instance of the service. And these infrastructures in themselves, like I said, they are services. So if we change something, we can actually swap them in and swap them out. So for example, in here, we got that logging service, which in a testing environment can print to a shell, can do whatever. Or a config one, which in a testing environment can be something like a dictionary. But in production, we can switch that out with a service that deals, for example, with XML files or YAML files or whatever other files that we want to use. And that gives us really the power to actually say, you know, develop something quickly. You don't need any of the amount of big bits that allow you to scale. But just build something simple, and then later on we swap in the different services that have the same API and work in the same way. So if we decide to change anything underneath the hood, they wouldn't have to change anything. It's all pluggable. So now it's doing something, but you know that's one service and not very useful at scale still, because it's just on one single machine. So we've got this service provider here, which provides the interface to the service. It's pretty much a way of saying, you know, here's my service, this is how you're actually going to call the service. As you can see here at the bottom, you got your make movie service with our make movie magic, which we defined before, or we can actually change the logging level as well for the service dynamically. And then after the service provider, we got the proxy, and the proxy is pretty much a stand-in for the service that you're talking to. So it pretends it is that service, but underneath the hood, via Python duck typing, we can actually go and call something completely different. So you just pretty much go and call that method, but underneath the hood, we go off to a transport and actually publish that onto a transport, which is, for our terms, also a queue. And once again, those transports and those proxies can all be swapped in and swapped out. So here we got that queue, like I said, it's a transport. And at that point, you got a system where you can say, I got this transport, that transport. If one day I want to use RabbitMQ, which we tend to use, I can use RabbitMQ. If the next day something nice comes along, we can swap that out without having to rewrite the whole system. We just change the transport, which has the same interface. So that's one service. We can now go across to a different machine, but it's of course a bit of a problem if something just sits there and waiting, doesn't do anything. So we've got parallel processing that we implemented. So this is pretty much what we have been building so far. And we put a worker pool in front of it. The nice thing about Python, or some people say it's a bad thing about Python, Python threading is not necessarily famous for working very well. Even though you have 20 threads, it will still use only one CPU at a time, and it will just swap the context every single time, which is fine if you're doing CPA or heavy stuff. It's not the most optimal, but it somewhat works. It's a waste of time if you're doing IO heavy stuff. So Python has things that are called greenlets, which I think you also have in Go, which are called differently. But you can pretty much use those ones to actually optimize. So we can say up front, okay, this service is going to be very CPU heavy, going to do a very lot of CPU work. We're going to run it in a threaded environment. This one is going to talk to a third-party API, which is, a JSON, a REST API. We can use greenlets to take advantage of that, and actually, while we go off to that third-party API, we can do a whole bunch of other stuff. And once again, we can swap those things in and out, and we can actually tell the transport, oh, for this specific request, we're going to go and route you to that instance of that service that's running in a threaded environment, and for that one, we're actually going to go and point you to a greenlit environment. So we now pretty much have that little box that we have been building so far, and this pretty much gives us all the building blocks that we need to assemble a distributed system with the possibility to use pretty much the best technologies for the given tasks. But the nice thing that we can do is we can actually start chaining these blocks together. And that's what we did in production. So our pipeline is pretty much cross-language. Like I said, we use a lot of Python. I think 95% of our stack is Python. But we have a lot of C++. We got Lua. We got a couple of web tools. And we want all of these tools to be able to use in Manda because it's pretty much our interface to all of the data behind it. So what we did is put our first worker pool is micro whiskey plus Flask, which pretty much takes in all the requests, and pretty much any single language these days should be able to make, a web request or an HTTP request. If it can't, it's probably not worth using. So at that point, when you got that bit going, you can then use other things to pretty much proxy it out to different services. So that one here, micro whiskey and Flask, can scale by itself. It's pretty good at it. And then in the front end, what we call the front end here, we don't do anything else than session handling. So only the session handling happens in the service at that level. Everything else is being proxied across to RabbitMQ. We run multiple instances of RabbitMQ, but we actually don't cluster them together. We actually run just multiple instances because we found that the overhead of clustering and the request switching between one queue when it comes in on one machine and going to the other one is actually too much of overhead to what we do. So what we did actually is make sure that our worker pool and our transports can consume for multiple transports at the same time. So we can run 3 RabbitMQ instances and still consume continuously from all 3 at the same time. It's doing it round robin, of course, but it will still pull them off, and it will take the first one that has something available to do it, which means that we can use RabbitMQ, but we can also use RabbitMQ, ZeroMQ, and Redis at the same time without, once again, having to change anything. So we can pretty much build a system that for us works and for the need that we have. So we got something that is cross-language, something that's fault-tolerant now, as well with the RabbitMQ not scaling, and we use Nginx in front of that one as well, in front of the front end, where we can actually say do our round robin across different instances. So we run an active setup rather than just an active passive, pretty much for using everything that we can. So now that we got everything, of course we want monitoring, which is pretty much the bit that we really wanted when we wrote the system. And like I said, every single request gets assigned a request context. And as soon as the request comes in, or if it leaves the client, gets assigned a request ID that we can follow throughout the system. So if my service, my make service request comes in, or my make movie request comes in, if that goes off to the storage service, it will keep that same ID. And if that request decides to go across to Vancouver to make the same request there, that ID will follow it. So if it blows up in Vancouver, I can do a search on that request ID and actually find the whole trace throughout the system. And that's something that we found very, very important to have. And we got all of the information that we need, what host it was running on, what concurrency pool was used, all of this information that we needed. It also shows you pretty much the actual request overhead that we have. The request overhead of actually getting from the client through the system and back out is about 5 milliseconds. If we go above 10 milliseconds, people start noticing it because people work with demand on a daily basis. It is pretty interactive. It's not real time, but it is interactive. So if there's a slowdown of a tiny, tiny bit, people will start noticing. So we need to make sure that our limit is roughly about 5 milliseconds when we go through the overhead. So maintenance-wise, what do? We use Salt for deploying everything. We use it because it's written in Python, and we could actually extend it within a Manda module. So we actually can spin up services via Salt directly. And we actually wrap the Salt client itself in the service as well, because we don't want to log into that machine all the time to run with the Salt master, for example. We wrap it in the service, and we can actually make those requests directly from, once again, any language that we want to use. And it really gives us that predefined, repeatable configuration that we're after, because we've got to run this not in one site, we've got to run it across 8 different sites. So every single site has their Amanda instance, and we need to make sure that every single site is running exactly the same setup for that given show. So what we got is pretty much an adaptable, extendable, configurable, best-of-breed systems, as we called it. And we can pretty much build anything that we want, which is why we pretty much use this icon, because we can really plug all of those bits together as we want, as we need to. So looking at what I was still looking at, containerization. We don't want, if service A goes out of control and starts spinning up, with a lot of CPU, a lot of RAM, we don't want it to affect service B or service C or service D. So we're looking at containerization at the moment because all of our services run on the same machine. Of course, we've got multiple machines, but we don't split every single service onto one single machine. We've got multiple ones running on one machine, which is why we want containerization. The other one is auto-scaling. So at the moment, we decide when we need to scale up. We got a lot of metrics going on where we can see, okay, my queue length is getting too long, it might be worth spinning up a couple more services. We're also looking at actually open sourcing the system. So currently what we got in production, sorry, this is the PR slides that had to go in. We're currently working on the Jungle Book, for example, or a couple of other movies. And of course, we are hiring as well if you're interested in working on similar things. We don't look all that scary, but you might run into a couple of people like that after several hours of non-stop work. And thank you, yeah, any questions? Sorry if it went really, really quickly. Come and grab me afterwards if you have any questions as well.